Okay, today we're going to be talking about area of triangles and trapezoids. But first, I want to go back and just remind us of our area of parallelograms. We've worked with area of parallelograms before, our rectangles, squares, rhombi, our parallelograms. We already did that, and we found that the area of the base our area was the base times the height. That's how I would find the area of any parallelogram. And remember, area is the number of square units it would take to fill in that shape. Today, though, we're going to be looking at area of triangles. Now, if I know my parallelograms are the base times the height, I want you to look really carefully at those two parallelograms we're looking at above. Because if I was able to take this parallelogram and I cut it in half, what do I have? I actually have two triangles. And if I took that other parallelogram and I cut it in half, I should have, again, two triangles. Every parallelogram is made up of two triangles. So if I'm looking at finding the area of just one triangle, it kind of makes sense that my formula for area of triangles is going to be half of what I just did. So it's going to be half the base times the height. That's our formula for any triangle, the base times the height. So if you go ahead and look at these triangles right here, you can see what that base is. And we have to be very careful though, because we have to do the base. And remember, our height is our straight up and down 90-degree distance. So this would definitely be my height. But over here, I've got a nice 90-degree angle already. So my height would be this side, and that would be my height. In this obtuse triangle, there is no up and down distance inside the triangle to give me the height. So I actually have to go to that point, that vertex, go straight down and get that 90-degree angle. And then that would be my height. So your height isn't always on the triangle or in it. It might be outside of it. So I want to go ahead and look at our first example down here as we look at the area of our triangle. So the first thing I want you to do is find your base and your height. So let's go ahead and look at the base and the height. Here would be my base, and here would be my height. So I'm going to go ahead and just label them so I know this is my base, and this is my height. Then I'm going to write the formula, which I already did for you right here. Area is the half the base times the height. And then we're going to go ahead and replace those variables with the values that I know. Well, I don't know the area, so that's going to stay A. 1/2 is already a number. That base is 12 feet. That's what that base was. And then the height you labeled was 9 feet. Now to go ahead and solve it, we're just going to multiply. And I know I can do half of 12, which is 6, and then 6 times 9, 6 feet times 9 feet, is going to give me 54 square feet. And I did tell you right here, remember, it's square units when we deal with area. So that's the area of that triangle, 54 square feet. But now I want to look at trapezoids, because that's another quadrilateral that I want to work with to find the area. And again, area is the inside square units. And if I look at that, that definitely is not a parallelogram. But if I asked you, can you break that shape into, I don't know, do you see some shapes inside of those shapes? Inside of that shape? And a lot of times I hear people saying, well, yeah, I see a triangle here, I see a triangle here, and I see a parallelogram or a square in the middle. And if this one would go, you see a triangle up here on the top and kind of a rectangle on the bottom. Well, remember what I said about those squares and those rectangles as parallelograms. They're actually triangles. So I could take that trapezoid and actually break it into a whole bunch of triangles. So there's tons of triangles, 3 to 4 triangles inside every trapezoid. So it's going to be very much related to that formula right there of our triangle. There's only one difference, and that is I do have a base down here on the bottom, but unlike my parallelogram, the base on the bottom and the base on the top are actually the exact same length, same size. Here I have a base on the bottom, but that parallel side over here is definitely not the same size. So I have my two bases that are different lengths. So just so I can kind of keep it in my head of which one I'm talking about, I'm going to call this one base 1 and I'm going to call this one base 2. And again, it doesn't matter which one you make base 1 or which one you make base 2. The thing to remember is your parallel sides are your bases, and these are definitely parallel to each other. Now the height, which we still work with all the time, here's that height up in this one, is the distance between those two bases. So that 90-degree side, this would be my height. Now on this trapezoid, remember what I just said. Your bases are your parallel sides. So my base is not the top and the bottom, not for this problem, because those are not parallel sides. My parallel sides are actually my left and my right on this figure. So this is a base, and this is a base. But again, they're different lengths. So I need to label one base 1 and the other one base 2. Again, it doesn't matter, so I'm going to make this one base 2 and this one base 1 just for the fun of it. And then remember I said the height is that 90-degree distance between the two bases. How far is it from one base to the other? So this would actually be my height. So we have to be very careful when we look at it to label our base 1, 2, and definitely the height, and know what our figure or what those lengths are before I get started. Now the formula, like I said, is going to be very related to that triangle formula for area, since it does have many triangles inside. So it's still going to be half, but instead of that base times height, we know we actually have two different lengths of a base here. So we're going to take base 1 and we're going to add base 2 together. I'm going to take the two bases and add them together and get that sum. And then I can multiply it by my height. So area is going to be 1/2 base 1 plus base 2 times that height. And that's how we find out the area of the room inside the figure, how many square units it would take. So if I look at example 2 down here and I ask you to find the area of the trapezoid, the first thing I want you to do is I want you to label those bases and the height. You need to find those first. And again, remember, your bases have to be the parallel sides. This side, left and right, are the ones that are parallel. So those are going to be my bases. And again, it doesn't matter which one's base 1 or base 2. I'm going to make this one base 1 and I'll make this one base 2. but it honestly doesn't matter which one you do. Now the height, again, has to be the distance between those two bases. So 8 is actually my height. Now that I know what my base 1, base 2, and height are, I can go on to write that formula, which I already did for you right here. So the formula is area is 1/2 base 1 plus base 2 times the height. And then we're going to go ahead and replace those variables with the values I know from my problem. So area is 1/2 base 1. Well, I made the 9 inches my base 1. Plus base 2, I made that my 5-inch length. And now my height, well, that height was the 8 inches. So now I can multiply in order to solve. And here I have, let's do the parentheses first for that order of operations, and I get 14 inches times that 8 inches. Now we can multiply. What's half of 14? That's 7 inches. Very good. Times that 8 inches. 7 times 8 is 56. And again, it's square units. Oops, I almost put feet. Inches squared. So we're taking that formula that we used with parallelograms, and we're actually, every single one of these is kind of related to each other. That base times the height, and then with that triangle, it's half of the base times the height because it's half the size. And then, of course, our 1/2 base 1 plus base 2 times the height because we have those two different lengths of bases. So those are the formulas for area that we're going to be working with tonight for our homework. If you have any questions, go ahead and write them down and bring them to class with you.